Hey, welcome back. Let's do this example. Move the content of control register to C variable control reg. Here, control register is a special register of the ARM core. How do you read the special register, which is control register? To read a special register, there are some separate instructions in the instruction set. Let's explore that. In order to explore all the instructions of your processor, you have to refer to the instruction set document. But if you are using a generic user guide, then in this document itself, there is a summary of all the instructions of this processor. Just browse through this document and you will find a section, instruction set. Here, just click on miscellaneous instructions. Here it is. There are two instructions, MRS and MSR. These instructions you have to use in order to manipulate the special registers. Can't we use move instruction? No, move instruction can't be used because that is used for general purpose register. Here we are referring to the special register. That's why you have to use the dedicated instructions MRS and MSR. What MRS does? Move from special register to register. This we can use to read a value from the special register. And MSR instruction can be used to move data from register to special register. This we can use for write. Use these instructions. Let's understand the syntax of this instruction, how to use this. Click here and it would take you to this instruction details. Here you have to mention two details. One is destination register and the special register which you want to use. All these are special registers. In this case, I want to read control. I would use control here. And the destination register could be any general purpose register. The value will be copied from special reg to destination register. Let's do this. So the instruction is MRS. What is the source? This is a source, this is a destination. Source is control register. Fair enough. And this is a destination. In our case, destination is a C variable control reg. We can consider the C variable control reg as an output operand in this case, because that's a destination, output operand. The inline assembly looks something like this. This is a code section, and here this is a destination indexed by 0. This will be replaced by the first operand. We don't have any input operand, so this is empty, and we don't have any clubber list. This is empty. We have only output operand. This is a C variable control reg, and here we use the constraint string. The constraint string is now combination of two things. One is constraint modifier. This assignment operator is constraint modifier, and this is a constraint character. This constraint character will cause compiler to use register, isn't it, in the final instruction. What is the meaning of this constraint modifier? Let's understand that. Here is a constraint modifier is equal to. That means write only operand, usually used for all output operands. Whenever you are using output operands, you have to use this is equal to operator as constraint modifier. That tells the compiler that the operand is write only. That means the register what compiler has chosen for that operand will be write only. Let's try this example. Let me go to the IDE and let me create one more variable, control reg. Our goal is to read control register. Read control register to control reg. ASM volatile MRS %0 control. This is the output, colon, first open the parenthesis, give this variable name. We don't have any input operand, we don't have any clubber list. That's fine. You can terminate the statement like this. You need not to give 2 colons here. Even if you give that, no problem, that's correct. But I would not give that because that's not required. This %0 maps to this operand. Fine. Let's give the constraint string. Let's use R. It tells the compiler to use register for this instruction. So you cannot use I here because MRS takes only register as destination. You can go through the instruction details. Here you have to use is equal to modifier. That means this operand is write only. Since it's the output operand, you have to use is equal to. If it's the input operand, then make sure that you don't use is equal to, because input operands are always read only. This is write only. Let's try this, compile this code. Let me go to the list file, and here it is. There are 2 instructions generated. First one is MRS R3, control. That means the value of control register is copied into R3 first, and after that this is a write back. Write back from R3 to the address of the variable. R7 actually contains the address of this variable. That's why this is a memory write operation. So that's why always use a constraint modifier in the constraint string when you are dealing with output operands. Let's do this example. Copy the content of C variable var1 to var2. Here we use the instruction move, and the source is C variable var1. That we can consider it as input operand. And destination is var2. That we can consider it as output operand. This is how you write the inline assembly, __ASM, and you can use volatile here. I just omitted that. For the move, this is the destination and this is the source. The destination has to be the output operand. That's why I used var2 here. So with the constraint string, which consists of constraint modifier is equal to, because this is the output operand and this is the input operand. This is read only and this is write only. %0 refers to this and %1 refers to this. That's very simple, isn't it? Let's move forward. Copy the contents of a pointer into another variable. Here there are 2 variables. This is a normal variable, this is a pointer variable, and the pointer variable is initialized to this pointer. You have to store the content of this address into P1. You should do something like this. In C code you would do this. P1 is equal to star P2. That is you do by assembly instruction like this. Here we are doing memory read. We can use load instruction. We are using memory read. So this is a memory read. LDR, this is a destination, this is a source. The destination is P1. I can consider it as output operands. That's why I would keep that in output operand space is equal to R P1. That makes sense. This is the syntax of how you write the source for LDR instruction. Remember, like we write in a square brackets, we write R1, something like that. %1 here. This refers to the input operand. So the input operand is pointer variable. Let's try this example. Let me create P1 and P2. P2 is a pointer variable, and let me initialize P2 to some address. Let's say int star 0x2000008, something like that. And after that, __ASM volatile LDR %0 brackets %1. This is the destination. Output would be P1, and the constraint string would be is equal to R. That's correct. And now the input argument is P2. That's a pointer. Constraint string would be R. Let's end this. Fine. Compile this. Let's check the list file. Here it is. There are 3 instructions generated for this statement. Let's run this code to understand this better. Let me debug this project. Keep the breakpoint here. Let's examine the disassembly. For this line, these 3 instructions got generated. Let me keep a breakpoint here and let's turn on the instruction stepping mode. Let me hit run. First, what happens is R3 is populated. Let me hit single step. R3 is populated with the address, and after that R3 is dereferenced and the value is fetched again into R3. Let's see what happens. Let's do single step. R3 is 0. That's a value which is present over that address location. After that, that is stored back to this address. This is the address of P1. This is the address of P2. This is the address of P1. So like that. With that note, I would like to end this lecture, and we'll be using this inline assembly statements throughout this course. So whenever we do exercises which operate on the core registers of the processor. In the next lecture, I'll cover reset sequence. I'll see you in the next lecture.